Hey, hello, and welcome. Welcome to the show. It's me, JP, and I am here for another product pick of the week. So thank you for stopping by, and let's get to this. So first of all, who am I talking to? I'm talking to anyone and everyone out there, but particularly people who may know that you can go to the product page of this show to watch this show, sort of like a matrix thing. And this is where you're going to go. That's the URL right there. If you want to point a camera at that, you can head on over to the URL, which is adafruit.com/product/4471. That is going to put you right into the product page. And by the product page, I mean, and let me do a couple things here. So by the way, I'm going to check the chat for audio, both for levels, because I think I dropped the gain. There we go. And for lag. So if we get audio broadcasting again, we'll see if the audio sync stays healthy. Audio sync stays healthy? Did I say that right? And give me a moment, because I'm going to bring up the page itself here. This is where you want to watch this from, because we've got a 50% off discount right now if you head over to the product page. Bear with me while I resize this. It lost a window in the whole changeover, so I'm going to refresh that page, because this is what you should see is, look at that, half off, $3.25 right now. If you head on over to the page, and it's at product ID 4471, and it's the Adafruit MCP2221A. But I don't want to get ahead of myself, so what I'm going to do is I'm going to have Lady Ada go back a little bit in time and introduce for us. So here we go. Lady Ada, take it away.
Okay, so the MCP2221, and this is great because it's USB-C on one end, and then you get GPIO and Stemma QT and breakouts on the other end. And this chip, all it does is it takes USB HID data or CDC UART data and converts it for you, and we even have Blinka support. So what's neat is that you plug this into your computer, and now you can run all of our CircuitPython libraries and communicate with various sensors, LEDs, buttons, and devices. So for example, this here is a MacBook. You can see it's got a USB-C cable connecting to the MCP2221A on the side there on the table, and then it's holding the LSM6DSX 6DoF sensor, and as you're moving it, it's live plotting that data directly into your computer at full speed, again, without the need of any microcontroller programming. It's just pure Python, and you instantiate the CircuitPython library and just read the data. It's so easy. No soldering required, because you can just plug into the end there of the Stemma QT connector, which is compatible with QUIC. You can also use it with Grove sensors. This chip actually does a little bit more than I2C, although I like the I2C the most, of course. It has a UART, so it also comes up as a full RX-TX UART, so you can also use this for UART-capable sensors and devices like GPSs and some particle sensors. It also has 4 GPIO, G0 through G3, and they can all do digital in and out. They don't have pull-ups or pull-downs, it's a little bit annoying, but 3 of them have ADCs. It has a 10-bit ADC on 3 of those, so you can have 3 separate analog inputs, which is really nice. It also has a DAC, and it's only 5 bits. But, you know, if you want a DAC, you just want to do maybe some, basic analog control of some feedback circuit. It works great. Again, works with our CircuitPython API, so you can use it from Python 3. It's a low cost, but easy to use USB to I2C and GPIO adapter.
Bring physical computing to Python.
I
All
think
the
this is
sensors.
neat.
Anything
And
that
it's cheap.
Stemma plugs in, you can bring it in. $20? Are you kidding me?
You can also do sensor development. So if you're, for example, it's something what we do when we're writing drivers for chips.
Yeah.
Instead of dealing, we love microcontrollers, they're wonderful, but you are dealing with this extra board that's part of the interface, and it can crash, or it can, you can have a brownout because of power. With this, we plug this into the computer, we connect the sensor, we start writing our drivers, and we don't have to worry about having this separate microcontroller system.
Yeah.
We get the driver all written out in Python, and then we just test to make sure.
Eliminate
it
the
still
middle
works.
controller.
basically.
Yeah.
No middle controller here. It's
I think
direct.
this is just, this is that, I was saying it earlier in the show, it's a sleeper hit because there's a lot of people that know Python. They've always wanted to get sensor information in, and this is the way to do it.
We have our most popular.
And let's see if that fixes. And yeah, I'm kind of curious. Some people in the chat are saying that they're on Twitch versus YouTube. And I'm able to look over at the health of YouTube's stream. Let's see what it says right now. Right now it says it's in excellent health, but a moment before that it said no data. So we'll see if it's able to maintain that. So thanks for sticking with me. I still haven't licked this thing, and it's very weird because it happens on Tuesdays, but not on Thursdays. So go figure. All right. So if you're with me now. I'm not sure how far back that went weird, but what I'd like to do is show a little bit of a demo here. So the product pick of the week this week, it's this MCP2221A, and it allows us to plug in USB to the computer on one end, and then an I2C device or other GPIO types of devices, inputs, outputs. And in this case, I've got it hooked up to this light sensor. So this is a BH1750 STEMMA QT light sensor. I have it plugged in over the I2C bus into the MCP2221. And what I'm looking at right here is my Atom session. So this is the code that is running on the board right now. It looks a lot like a CircuitPython script. It's a Python script, and in this case what I'm doing is I'm bringing in time so that I can pause the board, and I'm bringing in the device that I'm using, this light sensor, BH1750. And all I do is instantiate it and print out its values. So with this setup, you'll see when I hit enter here, I'm telling Python 3 to run that code. Now, there is no microcontroller involved. This is just direct. So I've got USB essentially to my sensor. And now if I cover up this little sensor, you'll see we'll get 0 lux, and then we'll bring in greater lux. I'll turn on a little flashlight here. Let's see. There we go. Point that at there. It'll jump way the heck up. Okay, so that's running direct. Now, that's very similar to what you could do if you used a microcontroller, let's say a QT for example. You can send your information from a sensor to the QT, and then the QT can send serial data to the computer. But a couple of differences here. If I want to get data from the computer itself into this sort of ecosystem, and that's what I'm going to display here next, I've got a nice little OLED display here. And I've got some different code. Let's run this one here. So this is instead, let me stop that program running. So again, I got Python running on the computer. This is instead going to take info from my computer. In this case, I'm going to get my IP address off of my computer's Ethernet 1 or Ethernet 0, EN0 port. I'm going to grab CPU load data in percentage. I'm going to grab disk usage in percentage, and battery, which makes sense with a laptop. So these are all sort of system things that I can grab. Now watch what happens when I Python 3 stats.py. Oops, stats.py. Now what I'm doing is, oh, and I didn't show you the code as I was doing that, but that's okay. We'll take this out of here. So you can see now I'm getting the data off of my computer about CPU load. So this is telling me I'm at about 13, 14, 15% CPU load. This computer, this is a pretty fast computer, so it's often down in the like 2% when not much is happening. But now you can see I'm streaming this, this broadcast, and so I'm using about 16% roughly of CPU. And that would go way up if I did more robust things like some 3D rendering, some video editing. You can see disk percentage used, 0.8%, so not very full. And battery is at 100%. So here's the code for that. I didn't show that before, so let me bring that back on. So you can see here I've got Python code that's importing time. Again, I'm going to use that for sort of pausing if I need to. The board, which in this case is the MCP2221. And then I'm also bringing in this display, this OLED display, SSD1306. Then I'm using the Pillow or Pill library to do some drawing and image drawing of fonts. And then I'm importing PSUtil. So this is a utility that lets you use Python to ask the system things, such as the CPU usage, for example. I'm then setting up the I2C bus, excuse me, and I'm putting that display onto the bus that the QtPy is using. And then we do some display things like kind of clearing out the display with some black rectangles, setting up a couple of fonts. So that's how you can see I've got smaller typeface there for my IP address, just because it's longer, and then a bigger type for the others. And then I'm doing some things like asking about the battery power. You'll see here, these are this PSUtil, can do a check on the sensor's battery. It can check my IP address of my local area network on this device. And then I'm going and printing those. You'll see here, this is, I developed this on a laptop, so battery made sense. I'm now showing you this on a desktop. It doesn't have a battery, so this is a lie. I'm just saying 100% here, but this is normally how this would work. And then it displays that data, and then it updates every 10th of a second. So you can see there, that's a sort of second use of this. And so a couple questions actually coming from the chat that I'd like to address. And again, sorry about the audio sync if that's out right now. I'll fix it in the recap, but we'll live with it for now. So the question of, and let me bring up this, this full screen view here. I could take this one away. So there's a couple questions that come up with this. One is, why would you use a sort of GPIO and I2C breakout when you can just use a microcontroller? One reason that I mentioned here is that I actually am doing something where the microcontroller doesn't really make any sense because I'm trying to get my system health off of my computer and display it. And this is pretty cool because you can imagine, hold this up here, you can imagine this sort of thing. I haven't really known how to do a sort of elegant OLED system displayer of these kinds of stats before. It's the sort of thing you used to sometimes see on your PC computer case where you'd have like a little fan readout and a temperature readout from some of your devices. Let me get this thing to stay put. And that's just plain cool. I think you could imagine adding this to like a cyber deck or another type of computer build where you want to have little readouts of data. And pretty much anything that you can code in Python on your computer side, you can put on here, which means you've got a lot more processing power than if you're running something on a microcontroller. You could do things with really large data files that you're scraping offline and parsing. There's a whole lot that you can do given the differences in compute power of your computer versus a microcontroller. Another thing that I found that's actually quite nice is that in developing, and Limor mentioned this before, when you're developing, it can be faster to do your development on the computer, even if your target is going to be a microcontroller. So you're essentially in CircuitPython, things are already fast, so you're usually saving direct to disk. But I found things like libraries. If you're going to decide on adding a new peripheral and adding a new library, you're going to usually need to do a download of a CircuitPython library and then drag that over to your microcontroller and then go. If you're just working in Python, you can use a pip install. So you can do pip3 install thanks to Blinka, which gives us all of the CircuitPython libraries available on the computer. It's the same libraries, but you can get the Blinka libraries installed on your computer very quickly and easily with pip3. So you can do some really rapid iteration. At some point, you'll of course want to make sure that it's going to work on your target, which is your microcontroller. So you got to make sure things will fit into memory. You've not used too many devices to have too many libraries for the flash that's available and so on. So you know, clearly these are roughly the same price. This is about a $6 interface and it's about $6 for a QtPy. So they're both incredibly cheap, but you may find it nice to do some development on this board. Other use cases also can be just getting direct input from let's say, an analog input device like a potentiometer or something like that into your computer without an added microcontroller. And again, you're not coding something on your computer and coding something on your microcontroller. You can just work directly on the computer side of things. So it just simplifies things. Not saying one's better than the other, but it's an option. And another question was display I/O, why pill and not display I/O? I had just done a project on a Raspberry Pi using pill, and I had some similar code that I just wanted to use on this, so that was why. I'm guessing you could use display I/O. I just happened to copy and paste some similar code that I used for that MIDI merger a couple weeks back. All right, well, let's see. I think that takes care of the questions that I saw so far. Hopefully we're still streaming. I know the sync might not be good, but I'm gonna go ahead and call it. So another reminder, head on over to the page right here. This is product 4471. And in here you can get the discount right now during the show, during the live stream. It's $3.25, so it's hard to beat. If you want to pick up 1 or 10, you can do that right now. Check out the Learn Guide for information on setting things up, and it'll take you through the whole process on Windows, Linux, or Mac OS. And it gives you some examples of different libraries you can use. And then, of course, one of the really fun parts is you can then take any of your Stemma QT I2C devices that you may have on little breakouts, plug them in, and just start using them right on your computer, right inside of Python. So that's going to do it for today. That is my product pick of the week. It's the MCP2221A. It's a USB to I2C breakout board. Thanks so much. That's another JP's product pick of the week, and I will see you next week. Bye-bye.